Welcome to Natural Questions, a hot new game show where question answering systems are evaluated on Google queries. I'm your host, Exact Match. Let's start with our first question. Who is the Chief Executive Officer of Apple? Do you know the answer, contestant 1?
Tim Cook.
Sorry, not what I have here. How about you, contestant 45?
Appreciate it very much, Tim. Apple.
Wrong again. How about you, contestant 88?
Timothy Donald Cook.
That's what I have here.
Wait, but Tim Cook and Timothy Donald Cook are the same person.
I'm sorry, that's just not what I have on my answer sheet. This is an actual example from the widely used Natural Questions dataset where your model gives a correct answer, but it doesn't even get the points because the gold answer annotation does not consider equivalent answers.
So to improve this situation, we introduce our work, What's in a Name? Answer Equivalence for OpenDomain question answering. As seen from the previous example, most QA datasets only have a single answer for each question. For example, in Squad, there's only one single answer for each question annotated. On natural questions, sometimes you get multiple answers, but this is really a result of annotated uncertainty rather than an attempt to cover answer aliases. On Trivia QA, you do get a list of aliases for each gold answer. And we will explore the effect of incorporating these aliases in model training and evaluation.
Before we can tell you how we add in alias, let's first take a refresher on OpenDomain QA pipelines. Given a question, a dense passage retriever transforms the question into a low-dimension space vector that is also home to the passage vectors. Then we pick the top k passages as the first step. After that, a BERT reranker model combines the question and the passages and picks the closest passage that is used for the last step to find the answer. Span extraction is trained to highlight the right answer based on the training data. So, based on the training algorithm, only one of the answers is labeled as correct. Which means, even though there are equivalent correct answers, they are treated as incorrect as irrelevant ones. Let's see how we can fix this with answer aliases. For answer expansion, we first look at the original answer in the freebase. For example, for the answer entity Sun Life Stadium, we extract the following aliases: Joe Robbie Stadium, Pro Player Park, Pro Player Stadium, Dolphin Stadium. We added all of them as the expanded answer set. There are two things we can do with our expanded alias set. The first thing is to evaluate our trained model with our expanded answer set. Specifically, we compute the exact match score of the model prediction with respect to every gold answer in the expanded answer set and pick the highest EM score with the final EM score. But we can also use the expanded alias set in our training. In the training, we treat the retrieved passage as positive if it either contains the original answer or the answers in the expanded answer sets. Then some originally negative passage now became positive because it matches the answer in the expanded alias answer set. And we train the OpenDomain pipeline on the expanded answer set. Now let's see how it actually helps.
First, let's see how many new answers do we have. Quite a few more, especially on NQ and Trivia QA, where most answers are entities. On NQ, it increases from 1.74 to 13.04, and on Trivia QA, it increases from 1 to 14.03. And the number of positive questions also increases for all datasets. Next, let's see what happens to the EM scores when we do augmented training and evaluation. If we compare the column of answer set with the column of single answer, we can see that the EM score increases for all datasets on the augmented evaluation. And when we include answer aliases in augmented training, we can see that such augmented training improves the performance of NQ by quite a lot. It improves a little bit for Trivia QA, but it decreases for Squad.
Let me jump in to emphasize, even if you do the original single answer evaluation, training on the extended answer set yields an improvement.
Now that we have gone through the numbers, let's take a look at the actual examples to see what is really going on. We look at the training passages that originally don't have answer match, but now do with the augmented answer set. While most examples are valid, we do identify some examples that are not valid, and here are the examples. For the first example, the alias France is not really equivalent to the original code answer Paris, and so it is not a correct answer for this question. For the second example, the context that the alias is coming from is not really answering the question. For the last example, the question is asking for a specific alias, which is different from the alias in the answer set. After examining 50 such examples, we classify them into 4 categories: correct, debatable, wrong, and invalid questions that are unanswerable due to annotation errors. The augmented answers are mostly valid for NQ, which explains its EM jump on the augmented training. But for squad, we find that the augmentation often surfaces wrong augmented answers, and this explains why it has a drop in EM score when doing augmented training. And we also show the breakdown of the different wrong augmentation types in this table. Next, we've sampled 50 questions that are originally wrong according to the original evaluation, but are correct under our augmented evaluation. We find that almost all of these examples are valid according to our manual annotation. This suggests that our augmented evaluation is indeed quite reliable. So in summary, our work explores the idea of incorporating aliases in model training and evaluation, and we have achieved some positive results. That being said, we believe that there is more future work to be done, especially targeting answers that are not entities. Thank you for watching the presentation.